That's how we work out where we put our holes on a plate. If the holes are too close together, then that risks what we call bursting, which is where a crack forms between the holes. So in a plate situation, with say 4 holes, we don't want to get those holes too close together, and we also don't want to have them too far apart. Okay? So we have a minimum and a maximum that we need to calculate. This is what I'm talking about plate design for. Now the minimum refers to the distance between the holes, but it also refers to the distance between the hole centre line and the edge. The maximum refers to the distance between the holes, and it also refers to the distance between the holes and the edge. So there's quite a bit of checking going on here when we do our plate design. So I'll give you an example of a very easy plate design. And you'll notice something else I do as well when we go along in this. Let's call that what we're going to be putting in here is a bolt, which is 16
Let's turn that off for a second and make sure I'm not giving you incorrect
information. That's the last thing I want to do. It's all right, when you get to my age, you occasionally have to reflect back on an answer, even though I know it, just to make sure I'm doing it right. Put that in my sequel. Lecture always tries to make things. You guys can't see what's behind me, can you? No? 5 minutes later, have a wee spell, just do what they did when I went to lecture in Otago University. They played a Bart Simpson's cartoon in between things. I thought it was quite impressive. Yeah. 9, 10, 11. So it'll be yes. So what you're normally given here is a bolt hole size. So if we had a bolt hole size of say 16 millimeters, we have a distance here of say 420, and a distance up here of say 370. So you've designed this plate. You know the bolt hole size that's going in it, and you've decided that they're the numbers that you're going to crunch for the plate. 370 by 420. Okay, so the first thing is, if we've got a 16mm bolt hole, what size is our bolt? If I was to tell you that in steel work, you always have 1mm right the way around between the hole size and the bolt to fit into it, what would the bolt hole size be? 14? 14 it is. Now when we do design on steel, we don't do it according to the bolt hole, we do it according to the size of the bolt itself, which is rather odd. I'm just going to go back to the notes that we had. There it is. Put that back on again. So the minimum between holes, the minimum is, so I'll just do here. Minimum equals 2.5 times the diameter of the bolt, which equals 2.5 times 14, which equals 14 and 14 is 28, and 7 is 35, right? The maximum equals, we just went over that before up the top, 32 times T or 300. 32 times T or 300. So what's T? T's the thickness. We better give this some sort of thickness. Let's call it 10mm. Is that fair enough? 10mm thick. So that'll be equals 320. But that's higher than 300. So the maximum for this one would be 300. The maximum of 300, minimum of 35. Now, when you're doing design of plates, it's a little bit like we go back again to sewing in Grandma's handbag, and we used to, she used to say to me, not that I ever did sewing, to do it as close to the edges as possible, and it's exactly the same with plate design. We push the holes as far as they can go to the edge of the plate. So quite simply, let's make this distance here 35. So that means that the distance between here and here is 350, yeah. And from here to here, 35, 35.
300.
300? Yeah. Now I can tell you right now that the 300 works perfectly, but this is a problem. So to get rid of that problem, we decrease it down to the 300 that we worked out. And that means that on the side, on this side, it's going to be
60.
60. Each side of it, 60 and 60 is 420, yeah. So I'll just recap on that. This is a very good example because it actually is a little bit more complicated than the normal one I normally do. The first thing we do is work out our minimum and maximum. The next thing we do is we apply that to this situation. Now you might have 3 holes or 4 holes right round. It doesn't have to be 2. Just doing a very simple one with 2 at the moment. So we applied that. We got 350 as an answer here. When we worked out our maximum, it was 32 times T, which is 32 times 10, which is 320 down here. 32 times 10. And that came to 320. The rule up there says or 300 millimetres, meaning that 300 is the maximum. We applied the 300, which increased these two to 60. I told you, once you get your head around that, it's actually something that's not that hard to do. So on assignment 3, when I say you can do your plate whatever size you want, make sure those things work. Because at least 5 or 6 students come up to me at the end of assignment 3 and go, I just did the maths for assignment 4 and my plate doesn't work. And I'm like, well, you had the chance for assignment 3. You must use the same plate as you used for assignment 3. I won't mark it wrong in assignment 3. I'll let you do your calculations. And but assignment 4, you have to do a detail of that plate for assignment 4, and it must work. The numbers must work. Yeah.
Do we need to submit our calculations with the assignment?
No. All you need to do is a detail of that, just to put it mildly looking down on it. It's going to look like this, and you've got a column like that, which you have to draw on. The column's going to be welded around here. I'll tell you the symbol you're going to need for a weld. And there'll be, I don't know, 4 holes you've got to fit into it around this and around those calculations there. It's a little bit more complicated with the column sitting there. But just recapping on the assignment, you've got a plate here. You've got the columns coming down, and at the bottom you've got another plate that bolts into the slab. So that bolts in there with dyno bolts, which are bolts designed for going into concrete. And up here, the bolts go into some sort of a plate which connects to the timber. Alright, so you've got you'll be doing a detail of that, like that and plan view. Okay. Once again, this is for information only, but it gives you an idea of the strength of the different types of bolts. Interesting, the commercial bolts have a strength of 4.6 compared with these bad boys down here, which are high strength structural bolts. Same size, same diameter, same everything, but basically double the strength. Don't need to worry about this as information only. There's no question from that. And this last part here is how to call up the distances across. You're going to have to also do a detail for assignment 4 of the purlins. So you've got a timber member there, and you've got these angles here, and you're going to have to do that as a detail as well. So when you're doing the detail, it's no use just putting some lines in there saying bolt or whatever. You've got to actually put the physical dimension to the bolt. This here, these examples here will help you do that. This is a bit that some students struggle a little bit with. If you're detailing a hole in plan view, it should look like this, unless there are countersunk. We don't have any countersunk this year, but we did a bridge a year and a half ago, 2 years, is one of the assignments. And on top of the handrail, I put a countersunk screw so that when students were walking across the little bridge, they didn't catch their hand on the bolt on the top. And so many students didn't bother looking at this to put the symbol correct. So the ones you're mostly going to be using are these symbols here. Now, with the bolts, that is all you need to do at the scale of 1 to 20. That's the plan view, and that's the sideways view. A lot of students get right into drawing up the detail of the bolt, the washer, the nut, the head, the screws, and all that kind of thing. It's not necessary. All you do in a 1 to 20 plan is call it up like that. If you want to, you can do more details on these ones here. And some students come up to me and they go like, well, we've only done 2 details. There's so many more that we could do. And I'm saying, well, that's up to you. If you want a job doing this sort of thing and you enjoyed that, then why not do 6 details? I mean, it all looks good if you take it to a job interview, doesn't it? Look, I'm capable of doing that sort of thing. But I'm only asking for a couple. Just going back to 2010 or 11 when the old diploma was finishing, everybody had to do a whole semester of structural drawing. And in my office there I've got many assignments, and you would do at least 3 assignments only on structure through the semester, then you had an exam. So those assignments used to be quite complicated, many details, etc. So you guys are getting a wee bit of a watered down side of it. So if you are interested in this and you want to take it further, by doing the detailing and modelling class as an option on the diploma, you will, in addition to getting something like 12D, you'll get, for civil, you'll get Revit, which is, can provide all these details at the stroke of a button, which is really good. Once again, you need to know what you're actually looking at and doing. You can't just hit a button and go, well, that'll do, and then send it out to the client. So there's different ways to detail angles, channels, U-beams, and T's. And there are various terms in here which I've decided are important, and I'm going to tell you the ones now. Girt. The reason for a girt being important in my mind is a lot of steel buildings have got girts on the side of them for holding up various things. It could be signage, it could be holding up entranceways to the building, doors, or anything that's going to lean up against the building. So a girt is a very popular term. If you're a surveyor, often girts stick out of the side of buildings, and they could well be the difference between the distance to the boundary. It could step up the distance to the boundary if you're surveying the building. A cleat or a lug also is another one that's a common term that students would normally come across. A chock. A chock is an interesting one. It's a small piece of wood that's placed in between 2 members for strength. Another thing to remember is splice. A splice is a joint for lengthening, not strengthening. That's a brilliant multi-choice question because the words strengthening and lengthening are very close to each other. But when you're strengthening a joint, that means you're making it stronger. We tend to do splices. Splice with timber is the same. It tends to look like this. So we splice the joint together, whether we bolt it or whatever, and that will carry on in each direction. It's meant for strengthening, but if you were to put an object on top of here, it wouldn't be able to withstand as much strength as, say, further along the member at this end. So you're not actually strengthening it, you're lengthening it. Lintel's another one, which is over an opening of some sort. So you've got a window, a door, and the lintel tends to sit here. In New Zealand, with our strong earthquake codes, all doors and windows need to have a lintel. Sometimes it's steel, sometimes it's a double timber member sitting over the top. Ties and structures should know automatically from your structures classes. Along with the portal frame. Portal frame looks very much like that one I drew there, which was in my own house in 215. Welding. Okay. So, in addition to everything else we've talked about, bolting, rivets, and all that, we also have welding. Now, a number of students just decide, look, this is a bit complicated for me. I'm not really interested in welding. I'll just leave the weld symbols off my assignment 4, and that's fine. You can still pass my course without worrying too much about welding. But I will tell you this much: you will require a weld symbol on there, and to get full marks. There'll be no penalty if you don't. You just will miss out on getting full marks for that section. It's different in plan view, so notice that I've put a bit of a something around here. While in plan view, a weld looks, I don't know, some countries in the world can't grow very good beards and other ones do. Okay, so it doesn't really look like my beard, it sort of looks like a beard that's more like, if I was to draw this properly, it would be more like that with a nice space in between. So no ISIS beards and no beards that look like mine, alright? That's what it looks like. You get students that think, oh, I'll just draw a great big bushy beard all the way around. It's not the way it looks. So with the sim, that's in plan view, all right? In sideways view, when we're looking at something, so down here, where this is welded on here, we don't actually show a beard of any sort. We show some sort of a symbol, okay? Now, I'm not going to tell you what that symbol is. I want you to choose it. What I am going to say is that it is a fillet weld, and it's 6 millimeters. And there's a number of things you have to decide. Now this here is kind of the key to it. So we have a golf flag if it's welded on site. We have a circle here if it goes all the way around. We have an arrow pointing to the position on the member where it's welded, so you probably will need an arrow. At this end, we tend to put, at the tail end of the symbol, we put the size of the weld. The size of the weld tends to be, if I blew that up down here, what a weld does is, it's like a blob forms here, and they'll go along a C, forming a blob, and that distance there is where you get your 6 millimeters from. It's not perfect, although I've seen some boats at the boat show which have beautiful welds all the way along them. I don't know who did the weld, it's absolutely perfect, but generally speaking, 6 is the minimum that they would require along there. Okay? So there's an explanation there, you'll need to read through it as your first clue to what the symbol looks like. Also, I'll get into the next bit in a second. And the weld types, We have down here, that's an explanation of welding two bars together. And there's an explanation of the weld itself. There's the one I tried to explain. This little table here gives the different types of welds. Fillet weld, there we are, it's given you an explanation of what a fillet weld looks like, but what it hasn't done is tell you which one of these triangles it should be. One says both sides, one says the other side, and one says just the arrow side with the arrows coming in. So you need to choose one of these three, and also whether it's a round sight weld as well. So one of those two is the one that you should put in there as well. And it gives some examples of how we call them out up accordingly. Now I've taken two of these in the multi-choice, this little box here. So make sure you revise that little box. One of them is a V-weld, the other one's a fillet, in terms of learning that. Note also that all of these is what we call butt welds. We've got terminology here with double meanings, isn't it? Interesting. So there we are, there's the lead length there, the 6 millimeters as described. And here's another little sketch. You can see the weld goes all the way along here, and there's the symbol pointing at it, the correct way to put your symbol in for the weld. Double fillet along here. Now that does look a bit like an Al-Qaeda bed, doesn't it really? It's not. It should be more like what I've done up there. This just got blurred. And that is the last of the steel. So you've got to choose this. All you're doing from the welding is choosing a symbol to use. And you may use any of this stuff here in your notes when it comes to your notes section. So assignment 3, you're going to struggle a little bit with your notes. There'll be some mostly concrete notes in there. Assignment 4, you're going to need to do notes on concrete, steel, and next week timber. The only thing from next week's lecture you need for assignment 3 is the call up for the timber. Otherwise, you can pretty much finish your assignment based on what I've just shown you today. And on your lecture, in half an hour's time or so, we're going to do a steel quantity sheet, and that will directly help you with your assignment. Also, what I'm doing in the lab is going to be your test as well. The example is exactly what's in the test, except for the numbers. I'll change it around the numbers. I will go over that in a lot more detail when it's leading up to the final test. You have got 2 plate designs to do in the final test. Okay? I can see you all wanting to pack up and have your lunch before you do the lab. Are there any general questions anyone would like to ask? Yeah? About your assignment or? Oh, yeah. You can ask that in the lab as well, but you can ask them here. Yeah. We'll see anyone who's in today's lab, we'll see you. Make sure you sign the roll. And whoever's got the roll, please don't put it in your bag. Bring it back down here.